The general term of an arithmetic sequence is Tn equals 15 minus 2n, where n is an element of the natural number set. So here we have 4 questions to do with its sequence. Press pause and try them yourself, and then when you're ready for the solutions, press play. So A, part 1. Write down the first 3 terms of the sequence. So just a reminder that an arithmetic sequence means that we have the same first difference, or the first difference is the same or constant. Okay, so what I'm going to do is write down my formula, which is Tn equals 15 minus 2n. I'm looking for the first 3 terms. So I'm going to swap n for 1, then 2, and then 3. If I was looking for the first 4 terms, I would swap it for 1, 2, 3, and then 4. If I was looking for the first 5 terms, I'd swap it for 1, 2, 3, 4, and then 5, and so on. N must be a natural number. N is an element of the natural number set. Capital N stands for natural numbers, which are positive whole numbers. So I have 15 minus 2n. I'm going to swap the n for a set of brackets and put 1 into it. So this will get me term 1. T1 stands for term 1, the first term. So 15 minus 2 times 1, well, 2 times 1 is 2, so 15 minus 2 is 13. So 13 is T1, the first term of the sequence. Then I do the same, but with 2. So I swap that n for 2, but with brackets around it, because I'm looking for T2, the second term. So I have 15 minus 2 times 2. Well, 2 times 2 is 4, and 15 minus 4 is 11. So T2, term 2, the second term of the sequence, is 11. Then I do the same with 3 to get myself T3, or term 3. So I swap that n for a set of brackets and put 3 into it. So I have 15 minus 2 times 3. 2 times 3 is 6. So 15 take away 6 is 9. So 9 is the third term of my sequence, or T3. So now I can write out my sequence. 13, comma, 11, comma, 9, comma, dot, 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 to indicate that my sequence continues on. So let's check, is it arithmetic? To get from 13 to 11, I'm minusing 2. And to get from 11 to 9, I'm minusing 2 again. So yes, the first difference is the same, so it is arithmetic. Part 2. Find the first negative term of the sequence. So we're going to use our formula Tn, which is 15 minus 2n, to do this. So first negative term means less than 0. So if we were to write out our sequence, so we worked out 13, 11, and then 9. So if we were to keep going until we found the first negative term, we would end up at minus 1. So minus 1 is the first negative term of our sequence, and it keeps going. So we have 13, take away 2 is 11, take away 2 is 9, take away 2 is 7, take away 2 is 5, take away 2 is 3, take away 2 is 1, and then take away 2 again, we get to minus 1. So minus 1 is the first negative term of our sequence. And then the sequence continues on, so we'd have minus 3, minus 5, minus 7, and so on. But we're interested in the first negative term, which is minus 1. So this is one way of working it out. But another way is to take Tn, which is 15 minus 2n, take our nth term, and let it be less than 0. So first negative term also means less than 0. So we write less than symbol, one of our inequality symbols. So our inequality symbols are greater than, greater or equal to, less than, and less than or equal to. So this is our less than symbol, and this means less than 0. So we 15 minus 2n is less than 0. So we basically just want to solve for n. So we carry the 15 over the equal sign, it becomes minus 15. Or you could just say you minus 15 to both sides of the equation to get rid of the positive 15. But taking the 15 over the inequality sign, it becomes minus 15. So we end up with minus 2n is less than minus 15. Then to get the n on its own, we divide both sides by minus 2. So dividing minus 2 by minus 2, we get 1, or just n, 1n, and n is the same thing. And then minus 15 divided by minus 2 is positive 7.5, or 7.5, because a minus divided by minus gives us a plus, so we have a positive answer. Now, because in this step we divided by a negative number, we have to flip this inequality the other way around. So it was pointing to the left, now it's pointing to the right. So less than becomes greater than. And this is a rule in inequalities. We flip the inequality when we multiply or divide by a negative number. In this case, we were dividing by a negative number. So we end up with n is greater than 7.5. So n is greater than 7.5. So remember, n is a natural number. n, so n is an element of the natural number set, means n is a natural number, which means it's a positive whole number. And 7.5 is not a whole number, it's a decimal. So we're interested in the first natural number that's greater than 7.5, and it is 8. The first natural number, the first whole number, greater than 7.5 is 8. So what we need to do is find term 8, the 8th term. So we can count along, that's one way. So term 1, term 2, term 3, term 4, term 5, term 6, term 7, term 8. Yeah, there we are, minus 1. Or we can take Tn, which is our formula, 15 minus 2n, and we swap that n for a set of brackets and put 8 into it. So it's 15 minus 2 times 8, and 2 times 8 is 16, and 15 take away 16 is minus 1. So minus 1 is the first negative term. So we knew that from the start because we could see it once we'd written out our sequence. But it is better to do it algebraically using our inequality symbol. Part B, Part 1. Find Sn equal to T1 plus T2 plus ... plus Tn, the sum of the first n terms of the series in terms of n. So Sn is similar to the nth term formula, which we have up here. So Tn equals 15 minus 2n. But the S stands for sum of series. So T1, which is term 1, gets added to term 2, T2, which gets added to term 3, which gets added to term 4, and so on. So we get the sum, which means add, of the terms in the sequence, but we actually call it a series because there's pluses in between. So a sequence has commas, a series has addition signs or pluses. So we already worked out the first 3 terms of our sequence, which were 13, 11, and 9. So we write them out again, but with pluses in between. So we have Sn equals 13 plus 11 plus 9 plus ... So we're going to get our Sn formula, our sum of series formula, which is pretty much going to get us the nth term for the sum of series. It's pretty much going to come up with a formula for us for this particular sequence. So the series formula, which is given to us in the formula book, is Sn equals n divided by 2, bracket, 2a plus bracket n minus 1 bracket d bracket. So this is our series formula, and we want to actually come up with Sn specific to this sequence. So we want to come up with a formula for the sum of series of this sequence. So we have a look at our formula and we see we have n, a, and d. So the n stands for the term number, the number of terms, which we don't have, which we don't want right now. The a stands for the first term, and the d stands for the common difference. So we can see 13 as the first term, so a is equal to 13, the first term. And d is the common difference. So to get from 13 to 11, we minus 2. From 11 to 9, we minus 2. So d equals minus 2, the common difference. So we write out our formula again. We swap the a for 13 with brackets around it. Make sure you've got brackets, otherwise you're going to write 213, which is incorrect. The 2 and the a is stuck together, so we have to multiply them. So we swap the a for 13 with brackets around it. And then the only other thing that we substitute for is the d, so we're swapping the d for -2, again with brackets around it. So n divided by 2 is the same thing as a half times n, so we can just swap n over 2 for a half n. 2 multiplied by 13 is 26. N multiplied by -2 gives us -2n, and -1 multiplied by -2 gives us +2. Then 26 plus 2 is 28, and we still have the -2n. So we have a half n multiplied by 28 minus 2n. So next we're going to multiply in the half. So we have a half times 28 is 14, so a half of 28 is 14. And a half times -2n is -1n. So a half of -2 is -1. And then we just bring this n down in front. So Sn is equal to n times 14 minus 1n. So now we have a formula that we can use for this particular sequence, this particular arithmetic sequence, to find the sum of any number of terms in the sequence. So, for example, if I wanted to add up the first 100 terms of this sequence, I would swap that n for 100 with brackets around it, and I'd swap that n for 100 with brackets around it, and then I just multiply it out. If I wanted to find the first 50 terms of this sequence added together, or series more so, since we'd be adding, I'd swap this n for 50 with brackets around it, and I'd swap this n for 50 with brackets around it, and then I'd multiply out, and so on. So now we have a formula for the sum of the first n terms of the series, and it's in terms of n, means n is in the answer. So we can see there's an n and another n. Part 2, find the value of n for which the sum of the first n terms of the series is 0. So that means, starting with 13, which was our first term, how many terms would we have to add on to it? So we're minusing 2 each time, so that when we added them up, we'd end up with 0. So if I write out all the terms, starting with 13, that was our first term, and adding on all the other terms up until I end up with an answer of 0. So the next term in my sequence was 11, because 13 take away 2 is 11. And then the next term in my sequence is 9, because 11 take away 2 is 9, and so on. So if I have 13 plus the next term, which is 11, plus the next term, which is 9, plus the next term, which is 7, plus the next term, which is 5, plus the next term, which is 3, plus the next term, which is 1, plus the next term, which is -1. And this might look a bit funny here, having plus -1, but we're adding -1, because that's the next term after 1. And then we're adding -3, and then we're adding -5, and then we're adding -7, and then we're adding -9, and then we're adding -11, and then we're adding -13. If we do this, we will end up at 0, because 13 minus 13 will cancel. 13 take away 13 is 0. 11 take away 11 will cancel out. 9 take away 9 will cancel out. 7 take away 7 will cancel out. 5 take away 5 will cancel out. 3 take away 3 will cancel out. And 1 take away 1 will cancel out. So you'll be left with 0, which is what we're interested in. Alternatively, you could just put all of that into the calculator and you will end up with 0. So let's see, how many terms actually was that? Because we're looking for the value of n, which means we're looking for the number of terms. So how many terms in our sequence, in this case it's a series because we're adding them, how many terms in our series did we have to add together till we got an answer of 0? So that's term 1, term 2, term 3, term 4, term 5, term 6, term 7, term 8, term 9, term 11, term 12, term 13, and term 14. So we had to add together 14 terms to get an answer of 0. So that's one way of doing it, but let's now check algebraically. So if we take our Sn formula that we worked out in part 1, so Sn equals n multiplied by 14 minus n. If we let that equal to 0 and then solve for n, we'll figure out what the number of terms is. So we do want an answer of 14. So n times 14 minus n, well, we start off by letting that equal to 0. We want to solve for n, get the n on its own. Well, the first thing we want to do is divide both sides by n to get rid of this n. So dividing on the left-hand side by n just cancels out that n. And then dividing on the right-hand side by n still just gives us 0, because 0 divided by n is still just 0. So we bring down the 14, we bring down the minus n, and it's still equal to 0. So you can really just forget about this n in front of the bracket. So we have 14 minus n equals 0, so we're going to minus 14 to both sides to get the n on its own, or you could say we're carrying this 14 over the equal sign, it becomes minus 14. So we bring down the minus n, we bring down the equals, and then 0 take away 14 is minus 14. So if minus n is equal to minus 14, then changing the signs, we get n equal to positive 14. So this minus becomes a plus, and this minus becomes a plus. So we change them to their inverse, their opposite signs. Alternatively, you could just say, well, you're multiplying by minus 1. Because ultimately, we want n to be positive. So minus n times minus 1, a minus by minus is a plus, so you get positive n. And minus 14 times minus 1 is positive 14. So n is equal to 14, which is what we already worked out. So we're asked to find the value of n for which the sum of the first n terms of the series is 0. And we work that out to be 14. So if we were to add together the first 14 terms of this series, we would end up with 0. So n is equal to 14.